in this section we will be working with compound inequalities. Compound inequalities, like the one shown here in this table, what you will see is an expression like this. This first one can be read as -1 is less than x is less than 2. The solution set for this, x can be any number provided that it is greater than -1 but still less than +2. So looking at the graph of this, let me start by numbering the number line here. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. The solution set is going to be everything in between -1 and +2. So I'm just going to shade everything in between -1 and +2. Now you have to stop and think, do we include the endpoints? Because we have strict inequalities here, we do not want to include the -1 or the 2 in our solution set. So the notation that we use, if you are not including the endpoints, if the inequalities that you have are either strictly less than or strictly greater than, you're going to use parentheses. If you have less than or equal to, or greater than or equal to, you're going to use square brackets. So here we have strictly less than. So at the -1 we have a parenthesis, at the +2 we have a parenthesis. Writing this same solution set in interval notation, we want to represent this interval right here. Everything from -1 to +2, not including the -1, so we have a parenthesis at the -1, not including the +2, so we have a parenthesis at the 2. Now for this next one, we have -1 is less than or equal to x is less than or equal to 2. The difference being here we will actually include the -1 and the 2 in our solution set. So filling out the number line, we have -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. I can squeeze a 7 in there. We have everything in between -1 and +2 again. We have all this in here. And we actually include the -1 and the 2. So I'm going to put square brackets at the -1 and a square bracket at the 2. In interval notation, again, our interval is from -1 to 2, including the endpoints. So we have brackets in our interval notation. This last one, we have -1 is less than or equal to x, but strictly less than 2. So on our number line, filling this out, 2, 3, 4, 5, 6. At -1, we want a square bracket, but at +2, a parenthesis. So our solution set is everything in between -1 and +2, including -1, but not including the +2. And the interval notation, -1 to 2, you include the -1, do not include the 2. Now moving on to example number 1, we have the compound inequality, -3 is less than or equal to n is less than 5, and we need to figure out which of these values are part of the solution set. The easiest way to do this is to graph the inequality first. If you can visualize the graph, it's very easy to pick out which values are in the solution set and which are not. So I'm going to fill out this number line down here. There's -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. At -3, we're including -3, so we have a square bracket. At 5, we're not including 5. So we're going to have a parenthesis at 5, and we're shading everything in the middle. All right, so now look at the values, starting with n is equal to -5. -5 is not in our interval, so -5 is not part of the solution set. If you look at the next one, n is equal to -3, -3 is included. So negative 3 is part of the solution set, as is 0. Now this next one, 4.99, not quite 5. So it is in the solution set. However, 5 itself, because we have strict inequality, is not in the solution set. And neither is 12. Moving on to example number 2, you're asked to write a compound inequality to represent each of these statements. So starting with part A, a number is greater than or equal to 5, but less than 8. So I'm going to let n represent my number. So n is the number. And let's take these two pieces of information and see what we can do with it. A number is greater than or equal to 5. So n is greater than or equal to 5, but less than 8. So n has to be less than 8. Now when you're putting together a compound inequality, you need to start with the smaller number on the left and have the larger number on the right. So we're going to start with the 5. Now if you look at this inequality right here, n is greater than or equal to 5 means that 5 is less than or equal to n. All I did is flip it around a little bit. I did not change anything else about the inequality. So 5 is less than or equal to n. N is less than 8. So we're just going to add less than 8 right here on the right. Now for part B, this is an application problem. My car's tank can hold a maximum of 20 gallons of gas. So I'm going to let G be the number of gallons of gas. And according to this problem, my car's tank can hold a maximum of 20 gallons. So that means that G has to be less than or equal to 20 gallons. Now if you look at this inequality, what this indicates is that G can be any number provided it is less than or equal to 20, and that's not actually the case. If you think about a car's gas tank, a car can't hold a negative number of gallons. So G cannot be negative, but it could possibly be 0 if the car is completely empty. So there is going to be a lower bound here. So G, we know it's less than or equal to 20 gallons, but it also has to be greater than or equal to 0 gallons. Anything less than 0, it just wouldn't make sense. So now we have these two inequalities that we need to put together into a compound inequality, starting with the 0. And again, kind of just flipping everything around here. If G is if G is greater than or equal to 0, that means that 0 is less than or equal to G. And then we also know that G has to be less than or equal to 20 gallons.